Alright, so we're going to start our review on heat and heat transfer. To start, we're going to watch a little video from Tim and Moby, and then we're going to work on the worksheet that you have there at your seat. So let's go ahead and take a look at this.
Dear Tim and Moby, what is heat? From Ashley. Is that your final answer? Yeah, you go phone a friend. When molecules are exposed to energy, they absorb it and become pretty active. In this excited state, they move around faster and bump into each other a lot. Temperature measures just how fast those molecules are moving. Heat measures the energy contained within an object because of its moving molecules. For example, there's a lot more heat in an iceberg than in a pot of boiling water. Sure, the boiling water has a higher temperature, but the iceberg is a lot bigger. The molecules in the iceberg aren't moving as fast, but there are lots more of them. All that motion adds up to a greater heat energy. The lowest temperature you can get is absolute zero, or about minus 273 degrees Celsius. That's the point where all molecular motion freezes to a halt. Right after the Big Bang, the temperature of the universe was in the billions. It was too hot for even molecules to form. Heating up an object can cause it to expand, because those excited molecules take up more space. Get it hot enough, and it'll melt into a liquid. With even more heat, that liquid will become a gas. Heat likes to even itself out. This radiator is on, and it's heating up the room. If we turn the radiator off, the temperature of the air in the room will gradually become uniform. Even though heat itself is energy, it takes other types of energy to create heat. Solar energy, light from the sun, sustains life on Earth. The chemical energy stored inside wood and gas gives off heat when it's burned. And speaking of chemical energy, the chemical reactions that happen inside your body also generate heat. Electricity heats up the metal wires in a toaster. Friction makes heat too, like when you rub your hands together on a cold day. Nuclear energy is stored in the nucleus of an atom, and it creates lots of heat when it's released by fission and fusion reactions. Geothermal energy is the heat that comes from deep inside the Earth, powering geysers and volcanoes. Well, Moby, can you tell us what heat is? Hey, get to the point.
Alright, so we see what heat is. Let's go ahead and bring up the worksheet that we're going to be working on today and kind of start talking about some things. If my mouse would work, it would be wonderful. We'll try this way. Yeah, good enough. Alright, so what we have here is just a worksheet. We're talking about not only heat, but how heat is transferred. There are 3 different ways heat's transferred. I'm going to try to write on this. We'll find out what happens. Conduction. As you can see here, conduction is actually, let's see, is it working? Oh, I don't know if it's going to work. Alright, conduction is the act of heat transfer by touch. Heat transfer by touch. This isn't going to work for me, so I'm going to put this aside. Convection, go ahead and write it in. Convection is heat transfer where the warmer temperatures rise and the cooler temperatures sink. All dealing with density. As those molecules spread out, they rise up. As they then condense down when it's cold, they'll sink back down. So conduction, heat transfer by touch. Convection, heat transfer where hot rises, and cold sinks. We've lost the lights in the room. Motion. Now I get to glow. Alright, we have radiation. Radiation is heat transfer by rays or waves. That'll be coming from the sun and so forth. So let's take a look. I have a couple examples. We're going to start by looking over these together, and then you're going to finish them on your own and show me this page before you can move on. Now, I will accept multiple answers as you go through this. You'll see that some of these have multiple heat transfers going on, but it says identify the method of heat transfer that takes place in each illustration. Some illustrations may have more than one heat transfer. So the first one, I see a toaster. I know that when I use the toaster, the little coils heat up and the heat transfers to my bread by radiation and the waves and rays. I also know that if I put my hand over the toaster, I can feel the heat rising up out of the little slots. So that would be convection. And I guess if you touch the toast and you find out, it's warm, you have conduction. So you can write those down. Rewind if I went too quickly there. I was going to write it down, but the Moby's not working today. You have all three heat transfers. And don't just write down all three heat transfers. Explain how they're actually working. All right, moving on. Number 2, we have the hair dryer. We have the radiation as the heat coils start up and they radiate out. Now we'll have convection as that heat starts to rise off, but due to the fan, it actually blows the heat away. So I'll have radiation and convection in there. The iron, I would say a majority of the iron is through touch. The iron is touching your clothes as it gets the wrinkles out. So you have heat transfer by touch. That's conduction. We do have the steam that comes up, so that would be convection as heat rises, and you'll have all of that. All right, so you have your definitions. We went over 3, and as you can see, there's 3, 6, 9 examples left. And what I would like you to do is pick 4 of those examples, figure out the radiation, the convection, conduction that goes with them, explain it, and then when you have those 4 out of 4 through 9 complete, actually 4 through probably 12 complete, come and show me, and if you have any questions, I'll answer them at that point. Very good. There is your convection, conduction, and radiation heat transfer review.